All right, so good morning, good evening, good afternoon, and welcomes wherever you're watching this. This is lesson 6.1. This was systems of equations using graphing. Now, I'm showing you guys this after we're doing elimination substitution because graphing is actually the best way to solve these. It's the easiest, it's the fastest when you're taking an assessment. This is what you do. Now, what I want to make sure you guys understand is when it comes to graphing, Desmos will give you the answer. So will a graphing calculator. But the trick is, today I'm showing you Desmos, and the other trick is understanding what you're doing or how to interpret the answers. That's the main thing, okay? It's not necessarily about getting the answer. Remember, for us, in my class, it's how do you know when you're breaking even in a business? This can be used on a business standpoint, where when you buy materials, you're up here, and then you would start on a graph. And then when you're selling items, you're down here and you're starting to sell. And the point where they meet is where you would break even. So you will use systems of equations. Will you write them down physically? No. But you guys will understand as you go forward how it works. Now for us, this is on the notes. So if you don't have the notes, pick them up from me. But this is talking about what are the actual possible solutions that you'll run into. One, if you get exactly one solution, the terminology we use is called consistent and independent. Consistent means there is a solution. Inconsistent means there are no solutions. So that is why these two are consistent, because there is a solution. Here there is not one, so it is inconsistent. In relation to these two, it's either independent, which means, ladies and gentlemen, you have one solution, or it's dependent, which means you have many or infinite solutions. So understand, use this table to answer the homework on Alex and to understand and look at these graphs. Okay, so first and foremost, what type of graph is this? Well, if it's two parallel lines based on what we just said, this would of course be an inconsistent graph. Okay, go back here to check. Inconsistent, there is in fact no solution. So if you want to write that down as well, you can. No solution. The other one here, the next, would be now you have an intersection, okay? So your answer would end up being, it is a consistent graph, and ladies and gentlemen, the dependent, it is independent, okay? Consistent, independent, means there is a solution and there is only one, and now what I want you to do is write down the solution so you know what it is. The solution to this equation is 2, -1. Sorry, I had to make sure. Over 2, down 1. That's your solution. Here is the guided practice. What I want you to use is use Desmos to answer these. Put them in, go from there. Good luck. All right, pause the video. I've had some new students watch this. Pause it. So and watch it and then rewind it if you have to, but just make sure you're stopping and doing this guided practice on your own and not just watching me the entire time. So when I do this setup here, ladies and gentlemen, I would go to Desmos, which is I have set up right here, and I would go to my first two equations, which here they are right here. You graph it, and there's the intersection. The beauty about Desmos is once you click on a line, okay, so if I click anywhere else, once you click on one of these lines right here, the intersections or the important points show up. Intersection of y, x, and if there's another graph, the intersection where those two meet. That is what I want to make sure you guys understand. So today, on this one here, my solution is -2, whoops, I don't think that's right. Oh, it is right, okay. -2, -1 is my solution set up. And then you would want to know that this is consistent and independent, okay? There's your main reasons. Now, when it comes to this, make sure you guys understand that's all I'm looking for. Graph it, so you guys know on your notes when you graph it, I'm not going to take the time to graph it. I want to make sure this video goes through without a hitch. The second one, -2,5 and x -5. When I do that, ladies and gentlemen, there's my new intersection, okay? It would be 0, -5. All right, this is once again, it is consistent and it is independent. This is the same over there. Write that down, make sure you know, graph it up. Now I wanted to make sure you guys had some more examples to graph. So please graph these three. Use Desmos. The reason I put these on here, some of you struggle with when you see this right here, y equals -3. This is when every point of y, vertically or horizontally speaking, is -3. Okay, so right here is where you would do the line, right? That's -3. Why is that? Now, ladies and gentlemen, what you want to do is move through the process, use Desmos to graph the rest. Now, I can know by hindsight, if I move the negative over there by solving, so this would be -2x, and then I get rid of this negative here, that makes this positive. So I know my other graph is at -1, and then my slope is a +2, so it's up to, just like that. Okay, so here's my other intersection. Let me change that color to, let's go black, change it right there so you guys see the contrast. So I know that this point here is -1, -3, okay? -1 over -3 down. Focus on the other ones and graph these up. All right, now what you do is make sure you guys have these. So this one here is x equals 1, that's that graph. You see, if I move that over, I know that my next point here is at 4, 1, 2, 3, 4. I don't have to use Desmos because I can do this in my head. This is going to be over here, that's a negative slope, so it'd be down 2 over 1 right there. There's my slope, so my intersection is 1 over, whoops, not negative. My intersection would be 1 over and then 2 up. And then this one here, if I do this line, so that would be at a 3, 1, 2, 3. And I know the slope is going to go over there, so it's going to be negative. So I'll be going down like this. And then this one here would be a positive x at -1. So if I go a positive x at -1, that means I'm going like this. And if I did that correctly, my line would have been there. So I'm over 2, up 1. There's that point. Make sure you guys use Desmos, or if you can figure it out like I did, graph it from there. Now I want to make sure you guys understand a couple different things with the notes. Sometimes when you graph a system of equations, you have to determine whether it has no solution. No solution would be parallel lines. One solution, where they cross, or infinite, where you graph it and then another line graphs right on top of it, okay? That's an infinite solution. And if it has one, name it. All right, this is why I like Desmos, because of the colors. Hopefully you guys can see this as you come through. So here's my first equation, y equals 2x plus 3. If you guys notice, it is red. If I graph the other one, that is asking you 8x minus 4, y equals -12. I turned it on, hopefully you guys can see that that went from red to blue. All right, so what does that mean? That means, ladies and gentlemen, this is the same line, so it is infinite. That is why I like this. All right, I know the intersection's right about here and the other one's right there. Like I said, something, I don't need it to be perfect, guys. I just need it to be represented so you guys know that it's the same line. It's infinite solution set. By looking at this, most of you probably wouldn't know right away that those are actually the same equations. If I were to solve this one for y, it will come out to be y equals 2x plus 3, the same thing. Most of us don't know that by looking at it. So what you need to do is graph it in Desmos, understand. The reason I like the Desmos is the color change. If you use a regular calculator and you graph those both at the same time, you'll look and you'll be like, I only see one equation. And you'll think, well, maybe I did it wrong or there's no solution. No, you did it right. It's just understand that it's a graph and then the other graph was on top of it, okay? The next one you'd want to do is graph a system of equations and determine whether it has no, one, or infinite. Here's the other ones. So when I look at this right away, I notice, ladies and gentlemen, that I got x minus 2y on both equations. So I'm thinking this might be parallel lines. I don't know for sure. So since you don't know for sure, you should graph it. Okay, here's the other graphs. X minus 2y equals 4. X minus 2y equals -2. And sure enough, if I zoom out even, they are still what? Perfectly parallel. So understand that aspect of it. Okay, these are parallel lines. One is at 4, the other one's at -2, and they look something like this. Remember, I'm not going for perfection, I'm going for close. no solution. Go ahead and make sure you guys know that. Work on these two, please. All right, pause the video if you have to, but graph these, okay? When you graph these, you'll find out, and I don't know if I have these on Desmos because I may have skipped it all day. Let me see here. Nope, I don't have them. I skipped them all day. What you guys want to do is, I believe, when you graph this one out, so let me do it in my head real quick. I know this one is the same line, so this one is infinite. All right, I remember that one. This one here, I believe the point is 3, 1, but I can't remember, so I would go negative x, and then change this to negative and that to a positive. So my intersection's at negative 2, and it's a positive x, so it's going to look like this, something like that. And then the other one here is going to be negative 2x, and then you would divide by 3. So my slope is negative 2 over 3. My positive point is at 3. So it's at plus 3 right here, because 9 divided by 3 is 3. And my slope is negative 2, so it's down 2 over 3. It should be right there. So my point is, it is in fact 3 over 1 up. Good guess. I was trying to see if I remembered that, and I did. This one here, graph it, it's the same thing, okay? Make sure you guys know. Most important thing is I have 5 questions here that are word problems, and this is where I gotta make sure you guys understand this is what's important for you guys as you go through. All right, so we're gonna talk about 2 individuals here, okay? The first one is gonna be, I assume you say that as Naresh. So we're gonna put Naresh here, and the other one is Diego. Is it D-I? Yep, D-I-E-G-O. Diego. All right, Naresh, a couple numbers with her, 20 miles and 35, but it's miles per week. We are setting these equations up as y equals mx plus b. They are linear equations after all, right? They're straight lines. So understand that setup. 35 miles per week. Ladies and gentlemen, if you have anything attached to per week, if I were to ask you, how much you make per hour, I say, if you make $10 an hour, how do you figure out after working 8 hours? What is your equation? Most of you would say, well, it's 10x, because 10 times 8 would be 80. So you know after 8 hours, you make 80 bucks. 10x, it's per hour, per day, per week, per whatever is the variable attached to it, okay? So 35x, because it's per week. And this would be plus 20 because Naresh didn't start at 0. They already started at 20, and now you're adding on to it. Same with Diego then. All right, Diego starts off, and he is going to go 25 miles per week. Okay, so he's going 25 per week, but he already started last week. He did 50. He got a little bit of a head start, but he's going a little slower. Now it asks to graph. Or to solve. Now this is where I wanted to make sure everybody got this one as well, because all day today it's been fun watching you guys say that this is a parallel line. So I changed the colors. This is purple and red. So the purple is the 35 plus 20, and the other one, the red, is 25x plus 50. If you look at it from here, you guys, a lot of you were saying, oh, those are parallel lines, there's no solution. Wrong. Remember, you're only looking at a tiny little area. So this is what you do first. First off, you select a line, okay? You can notice right now there's no dots here. You pick one of the lines. Does it matter which one? No. But when you touch it on Desmos, it creates a dot. The dots are always intersections. Intersection of x, intersection of y, and also intersection of another line. So it's very key that you guys do this. Now, you zoom out. There's my second dot. That, ladies and gentlemen, would be my intersection, right? Your formula is 20. Remember, y equals mx plus b. The b value is your intersection. Okay, so I start at 20. Do I see anything else? I'd zoom out one more. There it is. A magic dot has appeared. But what is that magic dot? If I were to zoom in on it, it would be where the 2 lines cross, and it looks something like that. So there's my variable. There's my answer, 3, 125. But here's the problem. Nobody cares about that. What we care about is, what does it actually mean? What does the x value mean, okay? So what it means is as follows. What this means is, if x is 3, remember, this is a time, and it's miles per week. So this is supposed to be, this variable represents what word? Weeks. So after 3 weeks, we have our answer. We have they traveled 125 miles. How many miles until they hit the same? 125. Focus on that. That is what we're looking for. When you take the quiz, the final, the test, that's the understanding that you guys need to have. Understand what exactly you're looking at and for. Okay? The next one here, there's an example. I'm skipping that because I don't care. Joe and Josh. Figure out Joe and Josh real quick. Here's a big key thing now. Some students today ask me, Mr. Steiger, when am I going to use this in the real world? This is a budgeting item that you would actually use because they want to buy a video game. Okay? We had talked about next holiday season in 2020 holiday season. The PlayStation 5 will come out. You have a year to save up. You might want to start saving now. Here's the issue with this. Let's talk about Joe, and then we have Josh. So with Joe, he has $14, and he's saving 10 a week. If it's $10, it should say, if you put in a per week, you guys would know this would be 10x plus 14. He's saving 10 a week, he's got 14. Josh has $26, and he is saving 7 a week. There's your equations. Graph them in Desmos and figure it out. I believe when I've had all my students graph it today, I'm pretty sure the answer is 5 and 54. If that is wrong, it's because I'm trying to do it off my head. Graph it and find out if it's right or wrong, which means after, I'm sorry, that should be capital A. After 5 weeks, they both saved $54. Enough to get a nice used game, right? Please make sure you guys understand the concept. It's not 5 and 54, it's what does it actually mean? Take them some 5 weeks, and then they both save 54. And then from there, who's going to start saving more? It's probably going to be Joe. Joe is going to start saving more beyond that. But up to week 5, once they hit week 5, it's the same, and then after that, Joe's going to surpass them by a long shot. Here's the real world examples. What I wanted to do in class today is kind of just show up and set up the equations. You guys can answer them, okay? You don't need my help to answer these by graphing them, but you need to make sure you set the equations up right. So let's do that real quick. So we have first and second elevators, right? First elevator starts out at the 4th floor. Nobody cares about the 4, but it's 35 feet above the ground. So if it's y equals mx plus b, remember b is our y-intercept. So you got to remember, you're looking at an equation like this, and you're starting at 35 feet. This would be 0. 35 would be way up here, right? So this is going to be plus 35. And it's descending. Descending is going down. If we're going down, that's a negative slope. 2.2x. There's our first equation. Our other equation would be 1.7x, right? Because it is, the other elevator starts at the ground and is rising at a rate of 1.7. If you want to write plus 0, you can. Don't have to. Understand you're starting here and you're going like this, and this one's coming down like that, and that's the intersection we're looking for. And I do have this one in Desmos, I believe. So let me pull that up because I wanted to show you this last piece. And where did it go? I did at one point, but now it's gone. Okay, so I'm not going to put it back in. Understand when you do get this out, it comes out to be like a decimal when you get the answer, but understand that the x value is time, x is seconds, okay, and then the y value would be your feet. So please understand that concept. All right, Olivia and her brother William, make sure you guys can write these equations. Olivia and William, when you start them out, okay, they start out together. It says Olivia rode at a speed of 20 feet per second. William is at 15 per second. To be fair, Olivia decided to give William a 150-foot head start. So he's starting 150 feet in front of Olivia, and then they go. When you figure this out, I believe the answer to this one is 30 and 600. So after 30 seconds, they hit and tie at 600 feet. Two planes are in the air. One is descending, one is ascending. Once again, same thing, okay? They're in flight. One is at an altitude. So we got our first flight. It's at 1,000 meters, okay? And is ascending, which means it's going up at a rate of 400 meters per minute. Okay, so there's your per minute aspect. So you know that's why it's this aspect. And your other one here, your second one. Second plane is at an altitude of 5,900. And then it's descending, which means going down at a rate of 300. Put that in Desmos, get your answer, and understand that your x value is minutes. So x is going to be minutes. And your y value is your meters and when they actually meet. So you would say after such amount of minutes, they would be at the same altitude or same meter mark. When we take our quizzes and tests going forward, I will ask you to do elimination. I will ask you substitution. But you don't necessarily have to do that. You can graph the system of equations and get the answer. Be smart. Get the right answers and understand how you do it, and then we'll go from there. Okay, next year in geometry art, the teachers may not want you to use Desmos, so that's why I started with elimination and substitution, because it's very important that you understand those concepts. When you get those down, then, ladies and gentlemen, everything else is fine. If you have any questions, please come see me. Do the homework. It's very short. Good luck, and I'll see you soon.